Alright, today is day 2 of Unit 4. Today we are going to answer the question, how do we transform exponential functions? So we are going to get a little more practice on graphing, and we're going to focus the most on what happens when we change the base. We want to know based on like the shape of the graph. So let's get started. So number 1, what you're going to do is you're going to start out by putting this into your calculator. Alright, so I already did that right here. So you're going to put these 3 functions into your calculator. y1 will be 2 raised to the x power, y2 will be 5 to the x power, and y3 will be 1.2 to the x power. If you would prefer to do these all separately, that's fine, but this is just easier. Alright, so now what we're going to do is we are going to press our second function button and go to graph. Okay, so that will give us the table. Okay, so if you look on your graph, sorry, it's very hard to see here. So what I'm going to do is I see that once I get down to -2, so I'm going to do my domain. I'm going to go from -2 to +2. So the next thing I'm going to do is I'm going to draw my table. Okay, so I'm going to do my x's. So all my x's are going to be the same. So I'm going to go from -2, 1, 2. Okay, and then I'm going to make all of these in a different color. So bear with me. Okay, so I'm going to call this y1. So we'll say y1. Alright, so this is 0.25. And again, I'm getting these right off of the calculator. So 0.25, 0.5, 1, 2, 5. Okay, and magically I filled out the rest of my table. I just pressed pause. Okay, so all I did was, again, I transferred what's on my calculator onto the paper. Again, the reason I do this isn't to give you more work, but on the Regent, this will be showing your work. Alright, so I'd say that's a lot easier than plugging in the x for each of those values, like we did yesterday. I would prefer probably just to do this. Okay. So the next thing you're going to do is we are going to actually graph these points. So just to kind of have a look, so if you see on mine, so if we go to my calculator is color, so it's actually going to make these all in colors. They don't correspond with the colors that I made my table with, but I just want to show you whatever is y1 is going to go first, y2 is going to go second, and then y3 will be graphed after that. So if I press graph, you're going to see, well, take your time. Okay, so there's y1. Here's y2. And then chugging along is y3. So what I want you to notice, number 1, is that they all go through 0, 1. Okay? So I do want to plot these on our graph. Okay, so what we're going to do, for every time we go to a coordinate, we're going to use the same x. So to do our green graph, actually I have the purple on, so I'm going to do the purple first. I'm going to, let's see, I'm going to start at 0, 1, because that's actually the easiest one. Okay, and then let's see, 1, 1.2, it's kind of up a little bit higher, and then up a little bit higher. Okay, and again, sorry I paused it, so you don't have to wait for 400 years for me to graph 3 lines. So, I graphed the purple, which is 1.2 raised to the x power. You can see that that one is the straightest. It's not as steep, it's a little bit flatter, okay? Then if you look at the green graph, that was 2 raised to the x power. That one is a little bit higher than, a little bit steeper than the purple one. And then 5 raised to the x power, that is actually the steepest one. So what you should notice is, as the b value gets larger, my graph will get steeper. Okay? So let's write a little sentence. Okay, so how did the change in base values change the shape? Okay, so let's say, so both of these, so all 3 of these graphs, as the base increases, the graph gets steeper, faster, and each of the graphs approach the x-axis but never touch it. So that's what happens with the base values. Also, if you notice, there's no a value. The a value is 1, since we're not multiplying anything to the front of those. So for all 3 of these, they all should go through their y-intercept, which is 0, 1. They all should be the same. The other thing to notice, so the reason why we will never touch this is because there is no there's no power that you can raise. So anything to the x power can never equal 0. That's impossible. This is impossible. Okay, b raised to any power, there's no way that it could ever equal 0. Impossible. Okay. So next one. So this one's a little tricky as well. So for this one, I did the same exact thing, but what I want to show you is more so notation, okay? So this is what I'm going to graph, okay? And I'll call this y1. Remember, a of x, b of x, those are just, that's just notation. So then what I want you to do is I want you to rewrite, so b of x is equal to this, but instead of writing a regular x, I'm going to write a negative x. Okay? So that's going to be my y2. Okay? Alright, so again, you're going to put that into your calculator. Just a heads up to put a negative exponent in, and mine is a little bit different. Actually, let me do a different one. Okay, so when you have these calculators, what you want to do is, so you could put 3 raised to the x power, okay? Now to do a negative, you're going to do 3 raised, you're going to do a parentheses, then a negative x, end parentheses. Parentheses are right here. Parentheses are right here. Again, your negative button right at the bottom. Okay? So you're going to do that. So I do want you just to graph that so you can see in advance. We got 1. And we got 2. We have a little crisscross. Okay? So again, you're going to look at your table, and I would like you to put that onto your paper. Okay, so here I have both of those put down. Again, all I did was I took the table that I just showed you and I just put it back down on my paper. Okay? So let me show you a few colors. So, okay, Y1 is our A. Notice that if my, so we know that if my base is an integer, so a number greater than 1, a positive integer, that it is going to be a growth. Okay? So that's when b is greater than 1. Okay? So for this one, what I need to point out is, so yesterday we talked about, so if I were given something like 3 raised to the negative 2, this is the same thing as saying 1 over 3 squared, okay, which equals 1/9. Okay, so if you did this in your calculator right here, you would get a decimal. But this is how you actually do this, all right? So what's happening is, so here we have our A. Oops, that didn't work out. Okay, there we have our A value, or our A, where's my highlighter? Okay. All right. So, sorry, I'll make this red. Okay, so then what we have is if we type this in, we see that, oh, well, they're the same numbers, but they're going in reverse order. So what actually happened is we reflected this line over the y-axis. We reflected this line over the y-axis. So this one, Christmas colors, okay, this one, okay, try my best, sorry. Okay, that one reflected. It is the same exact graph, the same exact points, but they are in the reverse order. So what is happening when you do this right here, when you negate your y value, or your x value, sorry, when you negate your x value, you are reflecting it over your y-axis. Okay? So let's move on to the next one. Okay, so now we have, again, the same function. We have f of x is equal to 3 raised to the x power. Now we're actually going to negate out front, okay? So to rewrite this, g of x is equal to negative 3 raised to the x power. Okay? All right, so okay, so what I did now is I put in both of the functions, so 3 raised to the x power and then negative 3 raised to the x power. So if you graph that, you will see that you have your regular y equals 3 raised to the x power, and then now it is reflected over the the x-axis. Oh, sorry, I am off. Okay, so okay, if you look here, again, make sure that you guys are copying down your tables. Now, I am not, if you notice, today all my graphs have arrows on them. I am not giving you a domain, so you should have arrows. Your graphs, although when you put them in your calculator, it does look like they touch the x-axis. I just got done telling you that that is impossible. Okay, there is nothing that you could do in your calculator, in raising something to a power that will give you the number 0. That is not possible. Okay, so it will never touch the x-axis. It will keep getting closer and closer and closer, exponentially closer, but it will never touch. So now here, if we negate the whole entire function, we are actually reflecting it over the x-axis. Okay, so this is essentially, so our coefficient, remember our a value where it goes through, is now not a negative, is not a 1 like we have normally, but it is a negative 1. Okay, So again, if you notice right here, all right, so really, so if you think of, right, y equals ab to the x power, so our first one, so f of x is equal to 1 times 3x, whereas our g of x is equal to negative 1. Times 3 to the x power. Okay, so that's why it reflects over the x-axis. So if we negate our exponent, it should flip over the y, and if we negate our coefficient, then it should flip over the x. Okay. And on to the last question. Okay, so again, at this point, you should be able to put this into your calculator. Okay, so again, put f of so y equals 4x into your calculator, 4 raised to the x power. Make sure you guys are hitting. So when you're putting this into your calculator, to get the exponent, you have to hit this button right here. Okay, that gives you the exponent. And then hit x. Okay, and then I'm going to graph. Take forever. Okay, so now what I want to show you. So for the next portion of this, and I want you to do this in your calculator. You can draw on your graph if you want, but I want you to do it in your calculator. Okay, so if you were to put this in your calculator, we want to know if g of x is equal to f of x minus 2. So what we do is we rewrite our f of x, which is 4 raised to the x power. Okay, so again, this is very similar to how you substitute in. Okay, so f of x is equal to 4 raised to the x power. So what we want to do is we want to take that and we want to subtract 2 from it. Okay, so this becomes our new function. So if you do that in your calculator, okay, so I'm going to keep that one in there because I want you to see how it shifts. So you're going to go up, okay, so caret. Now if you have a fancy calculator like this, you have to do the side arrow to get it back down. If you have a regular calculator, you should just be able to keep writing. Okay, so minus 2. Let's see what happens when we graph it. All right, so it shifted down 2. Okay, so it shifted down 2. So I know it doesn't tell you to do this, but if I were to change this to a plus sign, hopefully you're figuring out what's going to happen. There's my original line. And there's my new line. Up to. Okay? Alright. So now the next one tells us that I want to do f of x minus 2. Alright, so whenever you have something in parentheses, that's affecting your x value. So now, and if you want, you can put this in parentheses. It's probably for the best. Now what you want to do is you want to put this into your calculator. So what's going to happen is when you change your exponent, it's going to move it from left to right. So I'll show you in both calculators. So I'm going to do x minus 2. Oop. There's my original. And now you're going to see it's going to move to the right. So if I were to do x plus 2, it would move it to the left. Okay, we'll do more with this in the next lesson.